Hello guys, this is again Vivo Shukla. Today we will discuss how to design slab in Staad Pro V8i. Before creating any model, let us discuss today's problem. The structure you can see here consists of two fixed edges, this one and this one. These edges are fixed while the other two edges are free. So the problem says we have to create 6 quadrilateral elements, plate elements that will be of 4 noded. So let us open our software space, name it is as design by BS 2007. Go to the problem, go to the top view of the model. You can see this length is 6 meter and this is 4 meter, and here edges are fixed and here edges are free. So go to the edit menu, select the XZ plane, click. Now you see in X we have to take 6 meter and in Z we have to take 4 meter. Click on OK. Now create the nodes. Press escape. We have to join these nodes using generate surface meshing tool. Node 1 is connected to node 2, node 2 is connected to node 3, node 3 is connected to node 4, node 4 is connected to node 1. Type of mesh generation will be quadrilateral. Click on OK. In 6 meter we have to create 3 plates, while in 4 we have to 2. So in front of 6 put value 3, in front of 4 value put 2. Element type will be quadrilateral. These are the input values. Click on apply to get the resultant view. Take it to the top view, switch off the bits. You can see the plate numbers: plate 1, plate 2, plate 3, plate 4, plate 5, plate 6. Now the next question is, that is the basic data for the structure. Put the thickness, that is 300 mm. Before applying thickness we have to create supports. So go to the thickness. We can change the input unit, centimeter and kilonewton. Thickness 30 centimeter is equivalent to 300 mm. Click add and close. Assign to view. This thickness will be applied to all the 6 plates. You can see in 3D view. This is our plate, what we have designed. Now the next, Material constant default values for concrete. Now the next step is go to the support along two edges. These two fixed edges we have to apply the supports, while these two are free. So take it to the top view, go to the support page, click on create. Support type will be fixed. Click on add, highlight the support to create the support nodes here. Assign to selected nodes. The model we have created like this. Now the next step is to apply the support loads. Self weight, pressure load that is acting vertically downwards, and that is the temperature load. So go to the load and definition page, go to the load case detail, click on add. Loading type will be dead load. Self load is considered under dead load only. We have to consider the self weight. You can see here in dead load we have to consider self weight. Click on add, then close. Second load is pressure load. So we'll go to the load case detail. This time loading type will be none. We are specifying. External pressure load. In that we have to consider load on all the plates, then go to the plate load, pressure on full plate, and the value is 300. It is vertically downwards, so you have to put a value negative, and the direction will be GY since we are considering all plates. Then go to the third load, that is the temperature load. Go to the load case detail. Temperature change for axial elongation we are taking a value of 40, and temperature differential from top to bottom we are taking 30. Click on add and close. Now the time is to assign these values. Self weight is assigned to you. External pressure load is also to all the plates assigned to you. And temperature load is also to all the plates. And again, temperature load is also assigned successfully to all the plates. For uniform expansion. Now the fourth load is the combination of load 1 and load 2, and load 5 is combination of load 1 and load 3. So go to the load case detail, click on add, define combination, dead 1, external pressure load with a factor of safety 1. And fifth load is a combination of case 1 and case 3, that is case 1 and case 3. Again factor of safety 1.0, and the analysis type is linear elastic. Go to the analysis sprint, static check, click on add and close. Since we have done all this, now we would like to go to the change the input unit, that is meter and kilonewton. And then we will go to the analysis, print, post print, define commands, element forces or stresses, print element. Now we will again change the input units, meter and kilogram, and go to the post print again, define command, element force or stresses, print element forces. That is in kg. Print element stresses. Applying this particular to this plate number 3, you can apply to all the plates, but for this problem applying to this plate number 3 only. Similarly, print element force I'm applying to plate number 6. Assign to selected plate will be the assignment method. Click on assign. The properties has been applied, showing by green tick. Now go to the analyze menu, run analysis. Yes. Go to the view output file, done. You can see the results here. Total apply load, reaction load, element stress, plate number 3. And for the plate number element 4, 6. Close this. Now, since we are done with the modeling part, loading part and the analysis part, now we would like to design this particular slab according to Indian code, that is the IS 456-2000. But Bentley Systems has not yet implemented IS 456 code for the slab design Staad Pro V8i. So we have to use British code BS 8007 or BS 8110. Okay, so we have to use this British code only for the detailed design of slab. If you implement Indian code, it will show the just simple result, not the detailed result of the slab design. So before designing slab in Staad Pro, you have to use British codes. So go to the design tab, select concrete, select PS 8007, select the parameters, shift it to the left, critic strength FY main, click on OK. Go to the define parameters. You can see the values in kg, so we have to change the input units, meter and kilonewtons again. Click on OK. Now go to the define parameters, selecting M20 grade of concrete, and FY main will be 415. Click on OK. Now assign these two parameters to all the plates. Now I will go to the commands menu. I will select design slab oblique element. Click on that. Go to close. Select this element and click assign to view. Now the strength parameters and the design element has been set. Now go to the analyze menu, click on run analysis. Click save. Go to the view output file. You can see the results here. Applied load, reaction load, element stresses. These results you have seen before. You have to see the concrete design. You can see the element design to BS8007 and BS810. This unit, this particular thing you have not seen in IS456 code. If you have implemented that instead of BS8007 Staad V8i while designing slab, you can see element number 1, that is the plate number 1, ultimate limit state maximum movement, that is the mx and my. You can see here mx and my, longitudinal flexural strength and transverse flexural strength, the bars, center to center spacing, top and bottom, the cover by default they have provided, that is the 20, depth, width and cover, that is for the plate number 2, that is for the plate number 3, surface type is suspended. Slab can be ground or suspended. By default it is suspended. So this is the results of slab design in Staad Pro V8i. Systematic way to design a slab in Staad Pro V8i. Close this report. Now go to the post processing tab. Select all the nodes. See the reactions. Go to the plate. This is the way you have to design the. Now you can see that it has been designed. If it fails, all the things will show down. So you increase the moment capacity, strength of grade or strength of steel. You see reactions. Plate, maximum absolute. So that click. Now go to the deflection. This is the way slab is designed in Staad Pro V8i. Go to the notes, reactions, summary, fx, fy, fz, mx, my and mz, and the node information you can also see. This is we have designed 3D view. Change the lightings. If you want the reports, you can go to the reports. Okay. You can take picture also. Slab design for setup. This is a diagram, a close. Thank you for watching my tutorial. Please subscribe and share with your friends who is in loving softwares about civil engineering. And if you have any queries regarding this tutorial and my previous tutorial, and if you want some more tutorials, please subscribe me and post your comments, or you can mail me at my mail ID, that is career.vibor@gmail.com. So I would like to come up with new videos. Thank you very much. Stay blessed and stay raw.